turning them on and off is part of a way to get the signal back through the fiber to the optical line terminal. Since there's a whole bunch of devices competing to get back onto that single fiber, this is broken up by a time division type multiplexing, so that only one of these transmits at a time. So we'll take a look at that as we send some packets through there. Now this is a packet going out from the server, and this looks pretty much the way they did before. Now one thing is the color is different here than what we were using in the packet before. And I'm using that color to represent the wavelength, frequency of the light. We had a different color before that we were using for the optical. This is probably going to be a different wavelength, and there's actually two different wavelengths that are used because we're using a single fiber. The traffic going in one direction will be one wavelength, and traffic going in the other will be different. It won't be purple and green the way these are. This is just to indicate that there's different wavelengths of light. The signal actually splits, and those packets go on all the fibers connected to the splitter. That one packet just split in this passive device. Now, as they approach the optical network terminals, these are all addressed for computer number 2, so they'll be rejected by the ONTs 3 and 4, and that packet will just pass through to computer number 2. Now we're looking at some traffic coming back, and we're going to see a series of packets. They'll go out here through the optical network terminals. We just saw a couple go through. And we had on the first one is when it came through, that unit was turned on, and so the packet passed through there. And it got through before while this one was waiting in number 2. So the ones that were blocked down here at number 3. So the packet is held up waiting to get its time. You can see that number 2 is turned on right now. And now we'll see that just turned on number 4 ONT. You can see the green right here. This has just passed its first packet. Packets from the other ones have already made their way through. You can see the packet which is blue, one is on copper, now is in that purple color, traveling here on the fiber, and when it gets back here, it'll be back in the blue color. Again, the speed is higher in this part of the network and through the back plane of the terminal and the router, and you'll see that it slows down when it gets here to the server, when it's coming out of the computer. So this is just a sequence of these coming through, and even though some of them are held up with the different ONTs, they manage to form their way out here. You can see the spacing between them, and out here in the fast section, how close they get together as they get up here to the server in the slower section of the network. And so that's basically the way that the passive optical network works in terms of this time division of the signals coming upstream from the downstream ONTs, the OLT, and then a simple division on the way out of broadcast type of thing, similar to the old Ethernet networks using hubs. Then using the ONT to reject the packets that aren't intended for that particular address. Watch that again. Now, one point that you'll see here is that while all those packets are coming back towards the server, there's another transmission from the server that you see going out. See that number 4 there. Now this transmission that's shown in the green is going this time to computer number 4. So you can see now the number 4 here that it's passed through that ONT and it's on the way back. Another point here is that on the optical network, that green packet traveled in the opposite direction from these violet colored ones. That works perfectly well with the light in different wavelengths, so they don't interfere with each other. basically that's it. In the next video, we'll get into a dynamic bandwidth allocation, which makes this work a lot more efficiently.